Hello, this is Wafer Agent. When people think of a good wafer, they often picture a clean, round silicon disk. But in the wafer industry, a good wafer means something entirely different. Wafer quality is the most critical starting point. It determines the performance and yield of semiconductors. Today, we'll introduce the key quality parameters that define a good wafer. Wafer quality is shaped by two main stages of manufacturing. The first is crystal growing, the stage where a silicon single crystal is grown. The second is wafering, where the crystal is sliced and polished into a finished wafer. The key surface quality parameters include particle, microscopic contaminants on the wafer surface that can destroy circuit patterns; flatness, how flat the wafer is. Even nanometer-level height differences can cause focus errors in lithography; nanotopography, subtle surface undulations in the millimeter range that affect CMP uniformity; metal contamination, trace amounts of metals such as iron, copper, or sodium can alter device characteristics and reduce reliability; oxygen, incorporated during crystal growth. Its concentration affects both mechanical strength and electrical properties; carbon, another impurity from the growth process. High carbon levels can act as nucleation sites for defects. These chemical parameters are generally measured using FTIR spectroscopy for oxygen and carbon and ICP-MS analysis for metal contamination. BMD, or bulk microdefects, oxygen clusters formed during heat treatment. They can act as gettering sites to trap metal impurities away from active device regions. Slip, dislocation defects that form during high-temperature processing, typically at wafer edges, causing leakage current. Crystal defect, also known as COP, microvoids formed during crystal growth. When exposed at the surface, they create pits that can damage gate oxide integrity. These bulk and crystal defects are generally evaluated using infrared imaging and laser scattering techniques. In summary, a good wafer is not simply a clean silicon disk. It starts with a high-quality crystal, is free of particles, has excellent flatness, and is tightly controlled for metal contamination, oxygen, carbon, BMD, slip, and crystal defects. All of these quality parameters serve one purpose: to enable semiconductor manufacturers to achieve the highest possible yield. In the next episode, we'll take a closer look at particle and why a single microscopic dust particle can determine the fate of a chip. Thank you.